So I called this lesson various two-dimensional force problems. By two-dimensional, I mean there's going to be components. And the first one is the lawnmower problem. I'm going to tell you right now there's going to be a lawnmower problem on your test. In other words, I like example 1, I like example 1, I like example 1, I like example 1. Although I also like example 2, I like example 2, I like example 2. What do I mean by a lawnmower problem? It's where you have a flat ground instead of a ramp, but the force is coming in at an angle, like a lawnmower. Or you're pulling up at an angle, like walking backwards, pulling a lawnmower towards you. Okay? The key to realize in a problem, so this is a problem where we have vertical force components other than the normal force and mg, the obvious one. And the key to realize the normal force will not equal mg. This is where a good free body diagram and being very meticulous helps. If you're on a ramp, the normal force won't be mg cos. It'll be something different. But as long as you're careful with your free body diagram, we're okay. Ready to go, Noah? Oh, you got your formula sheet out. I like that. Okay. Example 1, well, Noah, what does A want me to find? Okay, I might not ask you to find the normal force, but that's the trickiest part of this. And then B, friction, it's going to be mu times the normal force, so mu times my answer from A. And C, acceleration. Okay. You know what it's a good job for? How do I know this is a free body diagram question? There's an angle and a force at an angle. I'm definitely going to be doing some components. You see it okay, Josh? Although, did they give me a picture? I'm going to label the picture instead of doing a true free body diagram. Okay? So what are the forces acting on this 50? Get the obvious one. What else? Bigger, smaller, or the same size as mg? I'm going to tell you right now, is there a force coming in at an angle? It's not the same size as mg. This force here, is it partly pushing down or is it partly lifting up? Okay? Compare that with this force here, which is partly lifting up. One of these will increase the normal force, and one of these will decrease the normal force. Pushing down on an object, does that make the normal force bigger or smaller? Well, the good news is one of you is correct. Okay, so you ready? Let's see if we can derive it. Is there an angle? Did I say angle? Everybody? What are my components here? I'm going to start and I'm going to go d, 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 d. This one's going to be down. Are we on a hill? No. So I'm not going to use parallel and perpendicular. You could. I'm going to go back to good old vertical, Fy, and horizontal, Fx. And I'm going to go color, 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 color. Okay. Let's go back. I would do that before I did the normal force, in the same way as we broke the ramp up into components before we tried to figure out the normal force. So Noah, I agree with you. Now normal force is next. In this case, everything down is going to equal everything. That's really what I meant when I said to you, is it sinking into the ground like quicksand? Is it flying like Superman? There are two forces down. Can you see them? What are they? I'll give you a hint. One of them's mg. 200 is not down. That's at an angle. We're never going to use the angled one. What? Fy, FYI. Yes. Okay. So now I'll ask you, is the normal force bigger, smaller, or the same size as mg? Can't be this. No, not the same. Okay? What is the normal force doing? It's canceling out. It's keeping this object from sinking into the ground. So it's having to cancel out everything down. How many things are down? So normal force is bigger. I'll exaggerate it. So here's what I'm arguing. Aiden, although technically, don't write this down, I'm pushing down at an angle. I'm going to argue that's the same as pushing to the right with whatever fx is, I don't know, and pushing down with whatever fy is. Those two combined are the same as that 200 going down at 20 degrees. Okay? Is there an applied force coming from off the page in this question? No. No. What did A want me to find? I'm going to figure, did I give you a whole page? I think I did. Yeah, I'll do the normal force right here. I'm not going to say, oh, but look, another force same size as the normal force. This is the more complicated question. I am going to say everything down has to equal everything. So everything down is mg plus fy. That has to equal, what's everything up? Yep. mg is easy. That's going to be 50 times 9.8. I need to figure out fy. Time to get tricky with it. Opposite hypotenuse. You know what would be really cool? It would be really cool if fy was sine. Really? So over here, I'm just going to make a little note. If I generalize this, sine theta equals fy over 200. How would you get the fy by itself? How would you move the 200 over? Multiply it. Is that okay, Josh? So I'm going to argue for part A, the normal force is going to be mg plus 200 sine 20. Now, look up once you've written that. So this was a tricky, a lot of you were having a tough time figuring out, is the normal force bigger or smaller? Now, normally, when you're done, Noah, look up. And Nick, that's okay. Normally, no pun intended, usually, in physics 11, that was our normal force, mg. Yes? Can you see we're adding to it, making the normal force bigger? Because you're adding something. If it was subtracting, the normal force would be smaller. I bet you that's what happens when you lift up at an angle, like in the next example. It's going to be a smaller normal force. Anyways, let's crunch the numbers. The normal force is going to be 50 times 9.8 plus 200 sine 20. Oh, I'm missing a 2. You get 558.404, blah, blah, blah. Okay. By far, the trickiest part of lawnmower questions is figuring out the normal force. Aiden, what's B want me to find? Mu times the... Oh, did they give me mu? Now, if they didn't give me mu, I'd have to find friction by writing a winner minus loser equation and getting the friction by itself. We'll do one like that too, but for now, I think friction equals mu times the normal force. It's going to be 0.1 times 558. I'm going to use my answer button. I don't need a calculator because multiplying by 0.1, Aiden, just moves the decimal point over 1. You got 55.8, right? I think, yes? Yeah. Okay. Cool. Wes, what C want me to find? Who's winning? That's the tricky part. Which way is this accelerating, if it's accelerating at all, do you think? I don't know what that means. To the right. So the winning direction is what? Same answer. Which is the only force pointing to the right? Fx. Do you know who's winning? Fx. Who's losing? Oh, I missed a force on my free body diagrams. Let's go back and let's add. There's definitely friction. And how do I know there's friction? Because there's a coefficient of friction. I think our tug of war here is Fx minus friction equals ma. What was Fy? Which trig function? Sine? Wes, what do you think Fx is? I'll make a little note in the margin. Fx is 200 cos theta. In fact, that's what I'm going to write. I'm not actually going to evaluate it. I'm going to go in my equation 200 cos 20 minus, I'm going to write 55.8, but hopefully you have that stored in your answer button. You can use that. Good. Divided by, what was the mass? 50? That equals the acceleration. Do you mind? I'll put the A equals on this side because that's where I'm used to seeing it. Brackets around the top. 200 cos 20 minus answer button divided by 50. Did I miss a bracket? No, I think I'm good. You get 2.64? Okay. What if I got a negative answer here? What would that mean? In this case, it would mean either it was decelerating or we weren't moving at all. If we were starting at rest, we're still at rest because we haven't overcome friction yet. Okay, so I need more information, but I would know that I picked the wrong winner. Okay. Oh, write down the answer, Mr. Duke. 2.64 meters per second squared. Okay. Example 2. A force of 18 newtons, I'll label that, is applied at a 21-degree angle to the mass below. If mu is 0.23, find the acceleration. So this is probably more likely than what I would ask in example 1, where I asked you to find friction and find the normal force. I probably asked you to do the whole schmear. Find the acceleration, and I expect you to clue in, I think I need to find friction. Oh, to do that, I need to find the normal force. You know what this is a good job for? Darn right. What are the forces acting on this car? And get the obvious one. Yep. What else? There's going to be a normal force, but it's not going to be mg. It's either going to be bigger or smaller. How do I know it's going to be bigger or smaller? I got an angled force. Normal force going to be bigger or smaller? Smaller. Now, just before we draw that in, let's bring in the components to confirm it. So we would have Fx, Fy, and I would say to myself, oh yeah, Fy is canceling out some of gravity, so normal force only needs to cancel out whatever's left of gravity. It's smaller than mg. Karn, I'll really exaggerate it. I'll make a little stubby arrow. Is there friction in this question? Yeah. Which way? Let's assume the block is sliding to the right. That would make friction pointing to the... Who's winning? Yes. Who's losing? And that's going to equal MA. Oh, divide by M. Hey, I got the A by itself. Did I give you the whole page? I did. Good. fx. Look at your triangle. Is fx cos again? Is it adjacent? It is? Oh, that's nice. So, Nick, you're telling me it's going to be, I've forgotten all the numbers, 18 cos 21 minus friction is mu times the normal force all over m. I might be tempted to take some shortcuts, but is it tricky enough? I go very meticulous. A is going to be 18 cos 21 minus, what's mu? Hey, what's mu with you? What is mu? 0.23 times the normal force. I don't know the normal force. And I can't say, oh, but look, because there's more vertical forces. So look at your free body diagram. We're going to do our little normal force calculation kind of over here. Are we sinking into the ground like quicksand? Are we flying like Superman? So that means everything down has to equal everything. What's everything down in that free body diagram? What's everything up? Two things. That's one thing. Yeah. I usually write normal force first, just because. How about I get the normal force by itself? How do we get the Fn by itself? Subtract what? Yes. So you're telling me normal force is mg minus Fy? Fy. Sine, you say? So you're telling me the normal force is mg minus 18 sine 21? So I got to be a bit careful. It's mu times that whole normal force. So it's going to be mu times mg minus 18 sine 21 all over m. Is that okay? All right, let's plug in our final set of numbers, and then we can crunch it. A is going to be 18 cos 21 minus 0.23 bracket. What was m? 7 times 9.8 minus 18 sine 21 all over 7. Sheesh. This is a fraction. Yep. More than one thing on the top. Oh, yeah. So definitely brackets around the top. Don't need brackets around the bottom. Oh. Close off the sign, close off the small bracket, close off the top. That's a tough one to type. Everybody get 0.35858, blah, blah, blah. See some of you nodding? If you didn't, don't clear your calculator. I'll come look at it if you want me to. Pause for a second. 0.35, I guess 0.359. 0.39, 0.359 barely accelerating. If friction was just a bit bigger, we might have got a negative answer, and then we would say this ain't going anywhere, or it's slowing and coming to a stop. I need more information. Okay. That's the lawnmower question. We're going to skip this, static equilibrium. We're going to skip this. It's cool, but we're going to skip something this quarter. Going to skip that. Going to skip that. Going to skip that. Going to skip that. There you go. That's my way of saying I'm going to ask you a lawnmower question, because I think that's a good putting everything together kind of a question. Okay? So for your homework, you can try number 1 and number 2. I got to cut corners a little bit here. 7 is good. Seven is a bit tricky. They're giving you, I guess somebody's pushing up the ramp. So when you, first of all, is this a ramp? Yes. The components are going to be parallel and perpendicular. You'll have one more force pushing up the ramp, and that's what you're going to get by itself. They gave you the acceleration, so you got enough information you can figure out the rest out. You can skip 8, you can skip 9, skip 10. 11 is good. Here's a lawnmower. $12 is good. Skip, skip. 15 is good. 16 is good. We are done Unit 2. You can now do any question on the ultimate dynamics review. That big thick package that I handed out before the break.